Thank you for the introduction. Hi, my name is Yoshi. I'm from Japan. My role at AWS is a developer advocate. So many of you may know the Howen here. He is my counterpart in China. My focus area is on observability and SRE, so that's the reason why I'm going to give a talk about Profiler. I'm so into open telemetry, open source project. I've been contributing to the project since its beginning. These days I'm a part of the documentation approval of the Japanese version of its documentation, and also I'm a part of the semantic convention SIG, the SIG member. So that's the reason why I'm going to talk about observability. So today's talk is about profile. It's okay if you don't know anything about profile, because I'm going to explain what profile is. So and what you need to know is that profile is one of the type of the telemetry you can get from the system. And also how you can, I'm going to introduce how you can use profile to investigate your performance issues on your program. And then I'm going to explain how you can use the profile data more effectively along with the AI assistants. So starting from what profile is. So what profile is in system, like in the system, is usually referred as a performance profile. So profile is the something that explains how well or how much the system is working well, and also how much the system is consuming the resources of the system or like of the OS. So the profile is the way to investigate resource consumption in the program, and also in a way that gives the information statistically on the specific resource usage. So this is the difference between the profile and trace. In the case of trace, you can track the resource consumption in a time series manner, but in the case of profile, you can get the statistical information throughout the specific period. So that's the difference. The famous tool of the profiler is Java Flight Recorder, which is JFR. Which is a native performance profiler of the Java. And in the case of Python, there's a standard library which is called the cProfile, as well as there's a third-party tool that is called Line Profiler. And also in the case of Linux, like if you'd like to get the profile from arbitrary executable files, then you can use the perf command. Anyway, there are a bunch of profiler tools in the world. So then I'm going to give an introduction why the profile is important when it comes to investigating the performance data. So here's some exercise for you. Okay, so imagine that you have some latency issue in your system. Okay, so you see some, like for example, you are running some web application, and then your client is sending the request to the web server, and then you find some slow latency from that web server. So then what you're going to do? So you need to do is to find out the cause of the performance issue and then fix it, right? And then when it comes to do such kind of investigation, these days, everybody says observability is important. So, and then everybody says observability is all about logs and metrics and traces. Okay, then let me see if this problem is resolved only with these three telemetry data, like logs and metrics and distributed traces. Okay, first, here is metrics. So you have metrics. Metrics is the most common type of telemetry you have, like CPU usage and memory usage and so on. Okay, and then so what metrics can track is the entire resource consumption of the instance or services. Right? For example, if you're running the web server on a container, then what metrics provide is how much that whole container is consuming the CPU or like memories from the container runtime, right? So what you get is the entire consumption of the container, and then it doesn't provide any information about which function in the application is consuming the memory or CPU usage, right? So still you can understand, if the web server is consuming the CPU usage a lot or not. But still, you don't find out which function or which implementation is causing the problem, right? So this is what metrics does. Okay, then when it comes to a distributed trace, it provides the really important information about latency issues. But these days, even though we have eBPF or such kind of native solutions, but still the common solutions for distributed trace is always about how you can instrument the system or a program. So as long as you instrument the function, you get the latency of the system, latency in a transaction. But if the function is not instrumented, you don't get any latency issue or latency information throughout the transaction. So that's a problem. So, and then it's really it takes a lot of work to instrument every single function in the program, and also instrumenting the trace, implementing the trace instrumentation in the program cause performance issue as well. So that's kind of ambivalent value that distributed traces provide. So anyway, as long as if you don't instrument the proper function, then you don't get any information about the cause of the latency problem. Then what logs provides? So what logs provide is if the specific function is doing specific thing at the specific timing, right? So as long as the function is handling the request properly, then it doesn't provide any error messages in it. Though the timestamp, maybe the timing of the event should be different, but still, what you get is, this specific process is done successfully, and then that's it. So as long as it doesn't have any errors, you just see the same messages from the log solutions, even if you have any latency problems. So here you get is that so logs and then distributed traces and the metrics still don't provide any information about what the cause of the latency issue. So this is a problem. So let's summarize the status. So objective of us to use the observability is to identify the cause of the performance issue and then fix it, right? But current status is that still there's a gap from the telemetry to the cause, because we just got is we have latency problem, and then we saw some surge of the CPU usage or memory usage, or if you see some latency change throughout the distributed traces, or we saw some logs that this function is handling the request well, but we still don't find out what the cause of the latency problem. So the ideal status here is that we are able to identify the code to fix the performance issue by line, so exact line. So, so this is the quote from the famous book, Observability Engineering. And then this is the definition of observability. So in control theory, observability is defined as a measure of how well internal state of a system can be inferred from the knowledge of its external outputs. So here, external outputs means telemetry. So we need to identify the exact cause only by the telemetry. So that is the ideal status of the well-equipped observability. So then what we can use. So here the profile comes in. So the reason why we need the profile is because we need to fill the gap between the status that 3 telemetries, logs and metrics and traces, could not provide. So by using a profile, you get the last 1 mile information from what 3 telemetry provides to the exact cause of the problem when it comes to fixing the performance issue. Okay, so now you got why a profile is important to fix the performance problem. So let me introduce how you can use profile to fix the performance problem in a traditional way. So how you use profile is the same as the other telemetry data, like logs and traces and metrics. So what you need to do is to instrument your program, and then you get the telemetry out of the program, and then you analyze the collected telemetry data so that you can identify the issue. So first step is to instrument your program. So instrumentation is always depending upon the library you use. So in the case of Go, there is the package called pprof, which is the standard package. So you can utilize the pprof out of the box when you install the Go on your system. And then what you need to do is to import pprof package in the program, and then create the instance of the profiler, and then start the profiler, and then and then define the where you stop the profiler measurement. So that's the way to do it. And then in the case of Python, the process is almost the same. So what you need to do is to import the package, the line this example is a line profiler. So you import the line profiler package and then enable it, and then write the specific part of the process, and then disable it. That's it. So like you start the timer and then stop it. The same. The process is the same. But this is the way to instrument the profile library in a batch system. So, but what you need to do in your day-to-day life is to have the profile instrumentation for long-running or more always-on type of system, right? Like a daemon or web server. So in that case, you can utilize the continuous profiler. So what the difference between one-off profiler and a continuous profiler is that one-off profiler is the same as the measuring the time of the 100-meter running. So just start the timer and then stop it. But in the case of continuous profiler, you need to have some function that accepts the trigger of taking the start signal out of the program, and then also you need to have another signal out of your program to stop it. Because the reason why is because if you're running always on type of system or program, say in the case of web server, you get a lot of requests at some time. That is called spike. And then when you realize a spike, it's always late to start the timer, because what you want to have is the profile data of the specific spike timing. But after starting the clicker, it is too late to start the clicker after the spike, right? So the solution of what continuous profiler provides is that to take the periodical profile data so for example, you can take 10 seconds profile data in every 5 minutes. And then those profile data can be stored outside of the program, like Amazon S3 and so on. And you can store them. And then if you realize the spike, then you can utilize those stored profile data to investigate the issue. So that's how the continuous profiler works. And then continuous profiler solutions are always available in many platforms. Say, for example, in the case of AWS, we provide CodeGuru. And then also there's an open source solution as well, which is called Pyroscope. It is now part of the Grafana solutions, but in the case of AWS, we have managed Grafana. So you can enable Pyroscope as well. So in both ways, you can use it. And also, if you're using other third-party observability solutions, then they have their own continuous profiler solution. So anything is fine, but important information is that you can use the continuous profiler from today. And then anyway, so you instrument your application with for the profiling, and then start collecting the data, and now you get now you can start analysis part. So this is the screenshot from the Amazon Managed Grafana along with the Pyroscope plugin. So now you know the statistical resource usage per stack, okay? And then this graph is called a flame graph, which is the famous way to visualize the profile data invented by the Brendan Gregg. And then, okay, so now what? So the person who just started using profiler or profile data may not be able to understand how to read this graph, right? So so that's the problem of usage of the profile. So profile is really valuable to the system operator or programmers, but still, in order to understand what the data shows, requires a lot of knowledge behind it, like the source code itself, and also how to read it, like what the visualization means, and also you need to have a fundamental computer science knowledge. So for example, if I read this graph, what I get is that, okay, so how to read is that if the bar is long, then it's consuming a lot of resource. In the case of this graph is visualizing the CPU usage of the whole stack of the program. So what you see is that, okay, so we see really long bars of syscall.read. So this is the system call of read, right? And then that should be called by some function. And then if we go up, then we find os.file.read. This is the standard library for Go to read the file, in a physical file in the program, in the OS. So, and then os.file.read is the standard package. So that should be well implemented by the main Go team. So that should be really performant. So what I get is that, okay, so maybe, my function, the function I've implemented is calling os.file.read in efficient way, maybe. So I get I take a look at the implementation of the cut function. So this is the just like POC function that imitates how the cut command of the GNU util is doing. And then what I found is that, okay, so this program is reading the file byte by byte. So that is really inefficient because every time it reads the 1 byte from the file, it calls the system call. So this is really inefficient. But without the computer science knowledge, so if the programmer doesn't know anything about the user land and then kernel land, they don't understand why this program is inefficient, right? So that's a problem. So to understand the profile data, the programmer or system operator had to have the specific level of the understanding of the whole system, like including program and then computer science knowledge. But nowadays we have AI assistant. So now you can utilize AI assistant to understand the profile data. And I personally believe that LLM fits more to the operations than the development, because in the case of operations, you have a bunch of context, such as a specification of the system and then telemetry data and the logs, everything. And then what expected is to have smaller outputs, like just the investigation and so on. Versus in the case of development, you need to generate a lot of source code, and then that should be really like large context for the model itself, and also that the output itself is really indeterministic. So I believe LLM fits more into the operation these days. And also the telemetry is important, because telemetry is the really important context for you to identify what's happening in a system. So given solving the problem for some performance issue or anything, error message, anything, you can utilize it more to identify the issues along with the AI assistant with the telemetry data. So let me do some demos on how you can utilize profile data to identify the performance issue. Okay, so now you have, is this working? Okay, and then so because I'm an AWS employee, I use Amazon Q Developer here. And then you can ask, like, hey, so please analyze the profile data along with this source code to identify the performance issue in the program. If I run it, it starts analyzing the source code and then profile data, and it realizes that it requires some tools to visualize the profile data. So I say yes, and then it shows the whole CPU usage by the stack, by the function. And then it identifies the exact function that causes the issue. So I say yes to deep dive into the function, and then it got the whole CPU usage information line by line, and then it identifies the issue, and then also it provides the improvement by itself. So this is how you can utilize the AI assistant more to fix the performance problem with the profile data. So this is the end of my demo. Okay, so this is the screenshot. Oh, what happened? Okay. So anyway, so the summary is that profile is the key for the last 1 mile information to link the performance issue to the actual improvement code. And also, traditional way to analyze the profile data requires a lot of knowledge of the system itself and then computer science. But using the LLM AI assistant, you can leverage profile data, and also you can educate yourself on how to utilize profile data to identify the issue, and then you can accelerate your development. So I hope this presentation gives you a new idea on how to utilize the profile data, and then I hope you will success on development. Thank you so much.